The master and slave transluminal endoscopic robot master, direct drive endoscopic system DDES, and Endo-Samurai platforms have been developed as next generation flexible endoscopy and natural orifice transluminal endoscopic surgery notes related systems. However, many issues still remain unresolved. The master system has been used for endoscopic submucosal dissection (ESD) of early gastric cancer in a few patients, but manipulations other than submucosal dissection were performed by conventional techniques using a standard flexible endoscope. In addition, these platforms consist of two forceps, usually grasping forceps and electronic knife for treatment techniques at the endoscope tip, and a master unit for remote manipulation. The manipulation of the standard flexible endoscopes relies on conventional manual manipulation. In other words, because the platforms themselves are limited to manipulation of two forceps, another trained endoscopist is required to guide the tip of the endoscope to the appropriate site for performance of the procedure. This requires perfect coordination between the two endoscopists. In this type of situation, if a platform to remotely control manipulation of the flexible endoscope were available, one endoscopist could perform all of the manipulations. If functions to enable manipulation of the flexible endoscope itself could be integrated into existing platforms and a completely novel type of intuitive manipulation achieved, this would pave the way for robotic treatment with versatility comparable to that of the Da Vinci system in the field of flexible endoscopic treatment. Kume et al., the authors of the present study, entitled Development of a Novel Endoscopic Manipulation System, the Endoscopic Operation Robot version 3, had already developed a second generation of the Endoscopic Operation Robot, a master-slave robot that uses two joysticks to provide 4-axis manipulation of current flexible endoscopes, including up and down angulation, left-right angulation, rotation, and endoscope insertion retraction. However, manipulation of a flexible endoscope in the gastrointestinal tract, particularly in the colon with its complex curvature, requires force sensation that combines the reaction force from the gastrointestinal tract as the endoscope is being inserted and the flexibility of the endoscope itself. Therefore, the authors developed an EOR version 3 with a master unit that senses force, has built-in bilateral haptic feedback that transmits a force equal to that applied to the master unit by the endoscopist to the endoscope tip, and that enables 4-axis manipulation with one hand. A patent for the system is pending in Japan. In the present study, the authors aim to evaluate the performance of the EOR version 3, a colonoscopy training model with scope insertion through the entire colon, which requires very complex manipulation of the flexible endoscope, was used. Here is a summary of the findings. Background and aims. The next generation of flexible endoscopy platforms such as the master and slave transluminal endoscopic robot master is primarily for remote control manipulation of forceps, but manipulation of the flexible endoscope itself still depends on conventional techniques. We have developed the Endoscopic Operation Robot EOR version 3, which incorporates haptic feedback to provide complete remote control flexible endoscope manipulation. The present study aimed to evaluate the performance of the EOR version 3 method. A colonoscopy training model was used with scope insertion into the cecum. Force during insertion and insertion time in seconds to the cecum were evaluated. The data were compared by colon zone and experience level, trainee or expert. Results. The mean insertion time into the cecum was 118.54 plus minus 89.42 seconds. Stronger force and torque were required for deeper insertion of the scope. Expert and trainee endoscopists differed in the insertion time to the cecum, maximum counterclockwise torque, mean clockwise torque and mean counterclockwise torque. Conclusion. The EOR version 3 has operability with which endoscopists can easily familiarize themselves.